So welcome to the workshop titled Integrating Evaluation into Planning for Impacts, using computer simulation to aid program implementation and integrated evaluation. In hindsight, 9 o'clock was too early to start. 9:30 is the right way to go. Lesson learned.
Oh, good.
Let me first set up the workshop. Let me sort of talk about the type of community we've been trying to build in the last couple of years. I think we've been asking the question: how can evaluations help in any program planning, program implementation? We've had a series of workshops that really call into question how should evaluations be planned to make it. So for today, we're going to be talking about computer simulation, but I just want to keep the kinds of questions we've been asking for the last couple of years in mind. I see a number of regulars out here. Firstly, the question we often start at the Evaluation Center for Complex Interventions is, how do we know whether it's health quality interior, whether it's CAMH, when they say we're implementing a program, that's YMCA, that you actually thought through in a serious way what it takes to implement a program. So when a civil engineer designs a bridge, you go through a very, very, very elaborate process of designing the bridge and saying actually the bridge is going to stand before you actually build the bridge. I'm not sure we go through the same kind of rigor, go through the same kind of testing before we build it. So I'm looking at the camera out here. So I think part of the kind of thinking we've been trying to do at the Evaluation Center for Complex Health Interventions is how do we build in better design concepts into the planning of programs? That's one kind of question that's being critical in the kind of work we do. A second kind of question is when we use words like collaboration, like partnerships, like evidence-based, do we know what the heck we're talking about? Like context. So I think sometimes our field suffers from too many buzzwords without clarity on what these actually mean. Just as the bridge won't stand if you're not serious about a whole bunch of measures. I think in a sense it's not surprising that a number of our programs don't work. So in that light, it's my pleasure to welcome Jonny Morell from Michigan, from Fulcrum Corporation. He's the editor of the Journal of Evaluation and Program Planning. He's been a friend of the Evaluation Center, but I think with his focus on evaluation and program planning, over the years he's been a wonderful collaborator. He's also the winner of the Paul Lazarsfeld Award for Theory.
That is true.
From the American Evaluation Association in the last couple of years. But critical to his work is a focus on uncertainty, a focus on surprise. And you can see with our interest in complexity, it's so interesting because I think far too often when we implement programs, we go around pretending as though we know the world. The reality is we only know a small part of it, even in cases when it's evidence-based. So Jonny's got the floor for about 45 minutes. Then it's on to Michael Hall, the Vice President for Research and Development from YMCA of Greater Toronto. Michael has been a regular to our workshops. He's been a regular respondent. Michael brings a very, very strong understanding of what it takes or what it should take to implement complex programs in communities. And let me be clear. At the end, the proof of the pudding is right there. I don't care how great an idea looks in a simulation model. The question is, so what? And I think, I'm hoping, and this is a discussion I had with Jonny the last few weeks, every approach we ask, we test. We're asking, so what? And I wanted Michael here to sort of say, this is great, but welcome to my world. So this is very critical. I'm really sort of saying, I want the far too often in these discourses, I think we get into far too academic a space without getting real. And getting real often means getting more complex. So that's, I think, it's very critical. My pleasure to also welcome Cameron Norman, principal of Sensei, a designer. Cameron has been one of the leading lights in the evaluation community in Toronto. But I think in recent years he's tried to really integrate design principles into his evaluation work. And I think we're really looking forward to collaborating with the Evaluation Center. Look forward to collaborating with him. I think it's one of the first sessions you're attending. But I felt you were absolutely ideal here because I thought where we are going with simulation is how do we come up with better designs. So very critical in a discourse like this. Jonny's going to have the floor for 45 minutes. Then it's on to Michael for 15. And then on to Cameron 15. I'm tough on time. 45 means 25, 15 means 15, so on and so forth. But I think what we found from these workshops is really it's the interaction. I think the variety of organizations around the table. I'm keen to see what your reactions are to the simulation ideas, what your reactions are to the community ideas, what your reactions are to the design ideas. Jonny, welcome.
Do I need the mic?
I think so.
I guess I better use the mic.
You do.
First of all, thank you for all for being willing to listen to me. I'm going to have a good time. I hope some of you do as well. Just as a quick background, I am an organizational psychologist, actually a social psychologist by training. Nobody knows what that means, so I tell people I'm an organizational psychologist, which is a little bit closer to people's understanding of the world. Again, by way of background, I've sort of throughout my entire career, I've lived two lives. One is very practical hands-on evaluation. Actually, for the last few years, I've been evaluating safety programs in railroads, and obviously, if you read newspapers, this is a matter of some concern these days. But that's really very hands-on. The Federal Railroad Administration will come to me and say, we've done this, right? We've set up a confidential close call reporting system. As an example, what happened? And when I do that, I'm really quite atheoretical. I sort of jump on it like a dog on a bone, and I'll say, okay, you know, what kind of data can we collect? What kind of research design can we put together? I'll cobble together anything I can cobble together as a way of trying to make some sense of what's happened. The other part of my life is a lot more cerebral and theoretical. I've done a lot of work on the nature of logic models and the nature of program theory, and let's not get into the question of whether those two are really the same or different or not, because that's a question to have at the bar. But I've done a lot of work on what it means to say that we have the logic model, we have program theory.
Okay.
So
Johnny, I'm not sure the mic is on. Let me just make sure that
it's on.
Can you not getting to?
No, I'm good.
No, he's got the other mic.
Yeah.
Can we hear?
Yeah. If you can't hear me, just sort of jump up and wave or something. So, I've done a lot of work on theory. One issue, as I said, is logic models and program theory, and the other is unintended consequences. The truth of the matter is, when programs have unintended consequences, the reason that happens is not very interesting to me because everybody knows it, and I didn't invent it. It really does have to do with the notion of the world as being an open system, not being able to predict it. So the question of why we have these kinds of uncertainties is really not too interesting to me. What I am interested in is what the implications of that are for doing program evaluation, which is a whole different question. So those are the kinds of things I do, and I like to go back and forth between the theory and the practice. When I'm doing real evaluation hands-on, I never talk about all this highfalutin stuff. But what I find is that what I have done with program theory does make a difference when I talk to people in the real world. So that's what I do. And what I'm going to do is sort of give you a sort of brief picture now of the sort of latest avant-garde crazy ideas that I've been thinking of. And that really has to do with this notion of using simulation as a program evaluation tool, and in particular, not any simulation, but simulation based on a complex adaptive system way of looking at the world. So what I'm going to do is to start out by laying out what you will recognize as a very traditional program evaluation. And then I'm going to give you a look at a real simulation to see how, if you do a simulation, you will actually see things about that program that you would not have seen otherwise. Now, a lot of people, when they look at this, don't think about evaluation. They think about program planning, and that's okay, although my personal interest is not maybe we should have done such and such different when we planned the program, but it's more maybe we should have measured something differently or done extra case studies or had a different control group or God knows what it might be. So that's my interest, but I understand that these conversations segue back and forth between evaluation and planning. So what I'm going to do is give you a quick view of the program that we're talking about evaluating, a quick view on complex adaptive systems, and then if you look on the left, that's a program called NetLogo. We are actually going to run the model, and you will see that what comes out of that model are insights that you would never ever have if you did a traditional program evaluation. So that is what we're going to do, and let us get to it. Does that work, or should I go to whole screen view? Whole screen view, I can do that if I can find the right button. Okay, whole screen view. We made up a program. Now, one of the things I have to warn you is that this thing is entirely made up. And part of the problem is that it looks pretty good. It really does. And people look and say, oh my God, that's how we would do this. You know, there is this caveat. If you ever ran a program like this, you would want to do a research literature review. You'd want to talk to experts. You'd want to figure out what should the program theory really be. But it looks pretty good, and it'll do. And one of the reasons we did it this way is that the simulation I'm about to show you was done on a shoestring, as in our spare time, and it only took a couple of hours. So we couldn't exactly get too fancy about this. But here we go. So here's a situation where you're trying to get therapists to adopt presumably a new best practice in a mental health setting. So we made up this little theory, and we said whether or not the new innovation is going to be adopted is going to depend on some organizational variables, some psychological variables, some clinical variables, and some social psychological variables, which makes sense. So the basic core of this is that if a therapist is confident in a therapy, which is in the middle, they're going to use it. If they're going to use it, they're going to observe the clinical outcome, which is the white on the bottom. If they like the clinical outcome, they're going to use it again. Right? Pretty straightforward. We then said, okay, let's modify that in a way. We're going to modify it by training, because presumably you're going to train people how to do this. If the training is any good, it is going to have a direct impact on their confidence. And it is also going to have an impact on clinical outcome. Because if they don't know how to do it, it's not going to work very well. Now, you might want to argue with me that this is not true, and maybe those arrows should be different. But as I said, we made it up, and it looks halfway reasonable, which is all we need for this demonstration. We then said that we have this variable called organizational support, which is in the bottom right. You'll notice that we hypothesized goes directly to therapist use. In other words, you might not like it, you might not trust it, but if your boss tells you to do it, you may very well do it. Right, so that's the way we set this up. The blue are organizational variables. Training is organizational because someone has to pay for it and give you the time to do it and so on. So we've got the organizational variables of training and organizational support. We've got the social psychological variable on top of that mustard color, influenced by others, and that's got to do with whether your peers use this therapy or not. And so all of that affects use and therapist training and so on and so forth. And the idea is that you could go ahead and build an evaluation doing this if you wanted to, right? You would operationalize the variables. You would say, well, what does confidence mean, right? And you'd figure out some questionnaire or observational technique or content analysis plan if you were to interview the therapist and figure out some way of figuring out you're confident and you're not, right? You'd measure that. You'd say, well, what does clinical outcome mean? And you know, depending on what the therapy was, you'd have some measure of clinical outcome. And so you'd go ahead training. What does training quality mean? And you'd figure that out. Are you giving them a test? Are you giving them, you know, satisfaction measures? Excuse me. Whatever it might be. So you'd go ahead and you'd figure out how to measure all this stuff. And then you would decide about a methodology. You say, well, are we going to just do case studies? Maybe there's a control group we can find somewhere. If this clinic has good clinical records, maybe we can do some kind of a time series analysis on sort of outcome and patient flow and what have you. So you'd conjure all that up, right? And so actually when I teach evaluation, what I like to tell people is that there are three pieces of evaluation. One is the program theory / logic model, right? And then there is measurement. Measurement are the indicators of what's in the model. So you'd say, okay, we have this thing called therapist use, and that's all very nice, but how would we really measure it? Sort of, I guess the jargon would be, how do we operationalize that variable, right? And you think about the methodology, and what I like to tell people is that the methodology is the logic in which the observations are embedded, which then allows you to make sense of it. That could be anything. It could be expert judgment. It would be content analysis of interviews. It could be a randomized control design. But whatever the logic is, you need to know what it is. You need to be able to defend it. And you need to take whatever it is that you're measuring and, you know, map it into the methodology and map it into the model, and off you go. Okay. And I don't know, I suspect that everybody in this room, if they were to evaluate a program, would do something not too much different from what I just described. So where do we go from here? Let's see. Don't need that. There are problems. You're going to give me the high signs on time. Okay. I have no fear. He's going to let me know about the time. Okay. There are problems in doing it this way. One is what I like to think of as that the act of developing a program legitimizes the program. I mean, I don't care if you tell people a program is innovative or not. You've put time in it, you've put money into it, you've put intellectual capital into it, you've put political capital into it. You don't really do experiments in this world. You don't always say, well, if there's data, we'll change what they do, what we do. I mean, in theory, that's true. In reality, that's not what happens, right? If you start up a program, it's going to go. Which means it's really important to get it right when you begin. What do we do about that? I mean, we work really hard at dealing with stakeholders. You know, why do you think this program is going to work? What are the implicit assumptions you're making? I mean, one of the reasons that I tend to make logic models is people say, well, we do this and then that happens. I say, well, you really believe that? Well, what's going to make that happen? I'm sure all of you have either been on the giving or receiving end of these kinds of exercises. And the reason we do that is because it's important to get those assumptions right, because if you don't get them right, you can't say, yeah, it's okay, we'll change it later. That's a great theory. You're not going to change it later in all likelihood. The problem is no matter how good we are at that, we're going to miss stuff. No matter how good we are at doing research literature reviews, no matter how good we are at talking to experts, no matter how much knowledge we have about how similar programs acted in the past, the reality is you're never going to get it exactly right. And that causes us all kinds of trouble, right? In lower right, what do we say? And you'll notice I used a different color because everyone needs to pay attention to this thing, right? Program behavior surprises us. Has that ever not happened to anybody? If anybody says yes, I bet they're a liar. The methodologies are unprepared to assess unexpected change. I mean, one of the big things for me is this notion that evaluation, that integrity needs to be maintained over time. If you think about research design, if you said to yourself, the only design I'm going to use is post-test only, no control group, qualitative analysis. I'm not saying that's a bad design. It might be a fine design, and it's infinitely flexible, because if the program is behaving in some way you didn't think it's going to behave, no problem, I can change the questions I'm going to ask. That's fine, but it means you're missing an awful lot. Whether you're doing qualitative or quantitative studies, sometimes you need to maintain the integrity of a design over time. And I'll pick an example, and I'll pick a qualitative example, because most people, when I say this, begin to think the qualitative-quantitative distinction. That's not true. I have a case study in my book in which it was I wrote a book on unintended consequences, and the way to do that was to get lots of case studies. It's a little bit like Tom Sawyer and the whitewash fence. You know, you have this idea and you get everybody else to paint the fence. I got a bunch of people to write case studies. So there was a case study of evaluating a refugee resettlement program. And it was a pretty cool design. They said, we're going to interview people when they first get to these resettlement camps, and then we're going to interview them, a few times in the future, and so on and so forth. Well, that's a pretty rigid design, actually, right? Because if you don't interview people when they first get to those resettlement camps, you're going to lose a tremendous amount of data. And in fact, that's what happened, because the people who paid for the evaluation said, no problem, you can do this. Didn't bother to tell the evaluators that by the time they were going to start, the refugees had already been at the resettlement center for 6 months or whatever. So that design kind of went down the tubes. But the point is, here's an example of a qualitative design where the structure of the thing matters. So I like to use that example because otherwise people fall into this qualitative-quantitative trap. But in any case, a false trap, I might add. But the point is that you're going to have trouble if you use if the program behaves in an unexpected way. And if you have any kind of an evaluation design that needs its integrity, it needs to maintain its integrity over time, you're going to be in trouble. Another example is you might want to measure something that involves validating a survey, where you're actually using a psychological scale of some point. Well, I don't know if anybody's involved in doing that, but it's a lot of work. You got to figure out the questions. You've got to get people to test it. You got to factor analyze. You got to do Cronbach's alpha. You got to throw questions out. You got to put them back in. You need to test them on a variety of populations. It's a big deal, hard thing to do. If you get halfway through an evaluation, you realize, oh my God, I should have been measuring something else. You're not going to be able to turn on a dime and say, okay, we'll just measure something else. Or let's say that this is a problem I have a lot in my work. I interview a lot of people in railroads. And it's not so easy to get permission to interview people in railroads. And if you've got an evaluation design that says, I need to evaluate the people who drive the trains and the conductors and the engineers, and then you get halfway through, this is qualitative design right now, we're interviewing people, but you get halfway through and say, wait a minute, that's not quite right. I also need to interview the people who fix the track. They're called maintenance of way, by the way. Well, that's a different division. I don't know the VP in charge of maintenance. I can't just say, okay, I'm going to negotiate with this guy now, and he's going to let me interview all his people in maintenance of way. It takes a long time. So you get all these problems of having to maintain the integrity of your evaluation, and depending on the methodologies you use, they're not easy to change. So how do you set up an evaluation that has these elaborate structures to it and yet is flexible enough to be able to deal with things over time? That's the problem I'm really interested in, and that's why I think that doing simulation is going to help. So let's see where we go from here, because I'm very cognizant of time here. Here's my fantasy, ultimately. Okay. And by the way, one of the reasons I have to tell you why what I'm showing you is an artificial example is that this is, I have a long list of ideas that people say, that's the damn best idea I ever heard. I'll say, okay, you know anybody who's going to pay for it? And the answer is no. So I'm sure you guys have lists like that too, and I do too. This is right up there on the top of my list. Fantastic idea. Can't get anybody to pay for it. But here's the fantasy. Right? Time one, you design an evaluation and you construct a model. And when I say a model, I don't mean the traditional logic model of the kind I showed you when I began. What I mean is an honest-to-goodness executable program model you can put into a computer and push the button and it goes. So the theory is that you design the evaluation, you construct the model, and that happens at the same time. So the people designing the program will say, here's what the program looks like. You design your traditional evaluation, but you also design the model, and you go back and forth. You can say to the people who are building the program, you're telling us to evaluate it such and such way because here's your program theory, but things are looking a little weird, and I can evaluate that, but maybe you want to think about the program design. So you do all that at time one. Then you get busy, time two, right? You conduct the evaluation. But the notion is that at the same time you're conducting the evaluation, you have data because you're conducting the evaluation. So you revise the model at time two, right? And then you get to the next time. This time you've got some cross-fertilization here because the model is going to tell you something about the evaluation and vice versa. Think of an example. The model builders say, I'm looking at your data, and you really said that X is going to happen, but we're finding that X is happening, but Y is also happening, and there's nothing in your interview protocols or your questionnaires to measure Y. You might want to build that in. So you go ahead and you do that. The evaluators come back with the empirical data, and you say, you told us that Y is going to happen, so we tried to measure it, and you were wrong about that, but we found out that Z happened, and we wouldn't have known about Z if we didn't try to measure Y. And then the model builders say, okay, well, if we know that Z is happening and not Y, we're going to adjust the model. So you can see how this goes on, and you're continually adjusting your evaluation. The reason I like that is because if you do it that way, you have lead time. You have more time between knowing when you have to change your evaluation and when you actually have to have that change implemented. And the more the lead time, the greater the likelihood that you can actually build in the necessary changes to evaluation. So there's my idea. Before I can run that, how am I doing on time?
You're right.
Okay. You've got your gong?
I do, yeah.
He's got his... All right, I'm expecting a big gong. If you're gonna, that's the way to do this. Okay, so where are we here? So what I'm going to do is run a simulation in a few minutes, and that simulation is going to show you how, let me just go back for a minute. There you go. It's going to show you how that picture, which was our original program theory, is okay, but not great, because you're going to see some behaviors that are going to show up that I suppose I could say you would never have anticipated. What I'm going to say is I would never have anticipated, but if I had to bet money, I'd bet money that you would not have anticipated it either. And we'll talk a little bit about the implications for program evaluation as a result, although I'm sure that all of you will see implications for program design as well. But in order to do this, I need to tell you a little bit about complex systems and modeling. And here was the problem that Sanjeev posed to me, because he said, oh, you got to tell them a little bit about complex systems. And I said, okay. And then he said, but you only have 45 minutes. And I thought, oh, okay, I can spend 45 minutes and not scratch the surface on complex systems, but we'll do our best. And by the way, these slides will be available, yes?
Yes, they will.
All right. If you need them in digital form, you can't get them from whatever source Sanjeev has. You can get them from my digital scrapbook, aka jamorell.com. That's sitting on the front page of the of the slides anyway. So we're going to do a brief diversion into the world of complex systems. And one thing I will promise you is that we will not talk about this slide. I stole this from Wikipedia. And the only reason I did this is that I wanted to give you some sense that complex systems is a big deal, complicated subject. Okay, and if you really cared, you could go to Wikipedia, you could look at each of these things, you could look up each of those circles, and you'd make yourself all very happy if you were interested in that subject. We're not going to do that. But there are a lot of good sources out there, and that's not a bad map. It'll give you some idea of how big this topic is. The reason I did that is because it's a little bit analogous to somebody saying, I'm going to analyze my data with statistics. So what does that mean, right? And people do that. I'm going to use I'm sorry, nobody does that. They'll never say, I'm going to use statistics. They're going to say, I'm going to use an interrupted time series design, or I'm going to do t-tests, or I'm going to factor analyze my data, right? Whatever they would tell you, because they know that it's meaningless to say, I'm going to use statistics. It's the same kind of thing. People are going to say, I'm going to use a systems perspective. Well, okay, what does that mean? That's part of the problem. And by the way, this is only a map of complex systems. If you want to look at systems in general, there's another complicated map that I guess Bob Williams has. So we are using complex systems, and I'm just going to give you a little bit of information about some of the more important aspects from this point of view. There is an awful lot more. I promise only 2 slides on this subject. That's a beehive on the right. I don't know how well it shows up, but that's a beehive, and I stole it from the web, and so you can see where I got it from on the bottom. I figured I should give people credit where credit is due. Okay. How does that happen? Bees are pretty stupid, right? I mean, bees don't know how to build hives. There's no master plan. The queen bee doesn't have a CAD drawing, with the bees, and a Microsoft Project PERT chart, and where you're drawing activities against resources and looking at the critical paths. Right? That doesn't happen. What happens is you've got a bunch of stupid bees, and those bees just have a couple of rules. Sniff out honey, lay down a pheromone trail. If you find honey, nectar I mean, go back to the hive, lay down a pheromone trail. You get to the hive, put the honey, put the nectar somewhere, right? And I don't know how many rules, but maybe 4, 5, 6 rules, however many are built into the hard wiring of a bee. But if you get enough bees and they all put things together, you get these complicated hives, right? That's called emergence. What emergence really means is that you have, I'm tempted to use the word complex, but I don't want to because that has a technical meaning I don't want to get into. You're going to get elaborate behavior that cannot be explained by simply looking at the sum total of the behavior at a lower level. That's what emergence means. It has to do with birds flocking. It has to do with innovation in society. It has to do with which R&D projects succeed. It's all over the place. But that's this notion of emergence, which is one of the more critical concepts in complex systems. It's also one of the more popular systems. I'm sure you've read about that in the newspapers and so on. And that's an important concept, so I figured I'd give you that one. And I'll give you...
Jonny, any health example that ultimately what most fields out here, any health example that you can think of that was sort of, where the idea of
Sure. Sure. I'll make it up, but I think it's maybe real. Does this come against my 45 minutes?
No, it doesn't.
All right. Just thought I'd check. Okay. Sure, let's say you're intervening in a community. Now, I'll give you a better example. I was talking... All right, let's say you're intervening in a community, right? And what you really want is a higher level of community well-being. I'm not exactly, you guys I'm sure know what community well-being means a lot better than I do, but presumably there's certain indicators of community well-being. What you would do is say, we've got lots of programs here. We've got programs to help individuals eat better, get more exercise or whatever. We've got programs to improve how kids learn in schools. We've got programs to improve traffic flow in the community. I've got all of these different programs. I'm stretching, it's not exactly emergence, but it's close enough. And we don't know the relationships among all of these things, but we know if we do a bunch of that stuff, this holistic notion of community health is going to reveal itself. And I didn't use the word emerge because emergence has, again, a technical meaning. This, I think, is a technical explanation. I think that might count as emergence. I'd have to think about it a little bit. But this notion that you get higher level system behavior in ways that you can't understand simply by looking at each individual change, okay? Because the concept of community health, whatever it means, and one of you guys should tell me, whatever it is, and I don't know what it is, isn't simply, I'm sure, the sum of how much the kids learn and how thin do people get and how much better does the traffic flow. So that's not technically an example, but it's the closest I can come up with on the fly. In fact, it's probably not an example of emergence, but it's close enough. The second concept I want to talk about, and then I promise I won't talk about anymore, even though I have many, many slides that I would love to talk about. And this has to do with path dependence. Does anybody remember from their stat classes what the general linear model is? Yes. Okay. People who remember will know that when they went to graduate school, they were taught to worship at the altar of the general linear model. Right, Sanjeev? You were taught to, yep. You guys too, right? What the general linear model really means, I'm not going to get statistical about this, but what it means, but it's a theory of how the world works. I mean, it's a notion in statistics, but it's almost theological in a way too. What it says is that whatever you want to measure, there's a score, a real score. So how far can a kid throw a baseball? How smooth is the traffic flow, whatever it might be, right? And you try to measure this, you measure this in an imperfect way, okay? And so what the general linear model says is there is a true score for whatever you're measuring and nobody knows what it means. If God comes down to earth and tells you what the true score is, then you know, right? But God doesn't come down to earth and tell us what the true score is. And so there's always error, right? We always get it wrong, right? But then we make an assumption. We make an assumption the error averages out to 0, right? And by the way, is normal distribution. It has to be normal, doesn't it? I think in general linear model, he knows more than I do.
No, that doesn't have to be.
Doesn't have to be normal, but it has to be symmetrical. And I think, you can correct me on that too. I think, doesn't it need to be symmetrical? Whatever.
Take time.
Okay, but it has to average out to 0, right? So the idea is if you measure enough units, whether it's traffic flow on corners or the intelligence of kids or whatever it might be, the error averages out to 0 if you do this right, and what you're left with is a good estimate of the true score. That's cool. And every time, let's not get into non-parametric statistics, but essentially every time you look at a statistical test or you do a statistical test, that's the assumption that you're making. Now, if you think about it, what this really means is that people don't matter, right? Corners in the city don't matter. Arcs of the baseball don't matter, right? Any single one of those is irrelevant. The only thing that's relevant is you have a lot of them. And if you have a lot of them and you measure every single one, then the error will average out to 0, and what you are left with is a pretty good estimate of, if God came down and told you what the real value was, that would be pretty close to the real value, okay? That's the way you and I and everybody else have learned how to do statistics. People don't matter, units of analysis don't matter. And here's that example, okay? Let's forget about the squiggly lines and all the arrows and stuff. Let's just say you've got time 1 and time 2, and you've got all of these dots, and these dots are corners in a city measuring traffic flow, or they are people and you're measuring health status, or they are military units and you are measuring readiness. It doesn't matter, okay. Well, at time 1 the average is 15, and at time 2 the average is 15, and if you took a statistical view of this, you would say, I don't care about any of those red dots, right? All I care about is that the average is 15, right? That's the traditional statistical way that we tend to look at the world, which is a good way to do it, by the way. I'm not against it. I do it all the time myself. But path dependence takes a different view of this world. Take a look at those circles with the X's in it, okay? And that squiggly enclosure is arbitrary, all right? At time 1, you've got an X on the outside of that arbitrary circle and X on the inside. But in a sense, it makes all the difference in the world. Because if you take the X on the bottom, at time 2, you're going to end up within that squiggly line on the right. And if not, you'll end up outside it. So all of a sudden, the system ends up in a different place. It matters. Right? Look at it again at time 2. You've got those 2 X's, right? In the statistical view, they're exactly the same. All you care about is that whatever number attaches to them, add that to all the other dots, average by the number of dots, it'll come out to 15. Nothing else matters. But with a path-dependent view of the world, it makes all the difference in the world. Because if you happen by random choice to pick the X on the outside, you know, you'll end up on the outside of that squiggly line. But if you happen to pick the X on the inside, you end up inside the squiggly line. And then you end up with, I didn't label it time 3, but it's that narrow stuff there on the right. And you see what's happening here. If by chance you pick the X on the inside the first time, and if by chance you pick the X on the inside the second time, where you end up with is a very different place than if you said, I don't care where those X's are. All I care is that they average out to 15. So that's what path dependence means. And so what it means is you don't look at the world in traditional statistical terms. Hey, am I talking too fast? Are you guys okay? Okay. If I'm talking too fast, somebody just go like that, because one of the problems is if you push my on button, it just keeps going, and when I have a tight deadline, it goes even faster. So if you need me to slow me down, let me know. But the point here is that I'm trying to illustrate the difference between the statistical view of the world and a complex systems view of the world. In the statistical view of the world, individuals don't matter. And when I say individuals, I don't mean people. I mean people. I mean military units. I mean trains. I mean schools. Whatever unit you happen to measure. Right? The individual unit doesn't matter. We only care about the average, and that's why we care about sampling and checking on error and all that stuff. Okay. But in the complex systems view of the world, random little choices between one unit and another can make a huge difference in where you end up later on. Okay. So that's really what I'm trying to show. And so the two important concepts have to do with emergence and with the fact that all individuals matter. And that's going to be important because in this model that I'm going to run for you, which has to do with therapists, obviously, you're going to see a graph where you're going to see two graphs. One is a graph of averages, but also you're going to see a graph of where every single therapist is at any given point in time. And it turns out that that is going to matter. I need to teach you a little bit about what an agent is, and then I promise there are many, many other slides which I would love to show you, but I will forbear. Although, when you unhide those slides, maybe when you put them up on the web so that people can see them. Okay, what does an agent mean? All right. Agent has very technical meaning in this sense, and that will matter. An agent is an entity. An entity can sense its environment and it can respond. Bees are entities, right? They can sense if there's honey there, nectar or not. If there's nectar, they do A. If there isn't nectar, they do B. Schools are entities, right? If the school, as a sort of reified concept, perceives that the public attitude towards education is getting better and better, it will engage in certain behaviors. If the school, as a sentient entity, perceives that the reputation of the school system is getting worse in the community, it will behave in a different way. Right? So an agent can be anything. Okay. But what's important is that it can sense its environment and it can make decisions. And that's all it cares about. What can an agent be, right? A person, an animal, a wetland, a hospital, a school, a county government, okay? I need to be careful because usually when you say agents, especially for someone like me, because I'm a psychologist by trade, actually I'm a psychologist by training, I'm not a psychologist by trade, you tend to think about people or maybe small groups of people. But in this world of ours, an agent can be whatever you need it to be in our system. So for instance, the example I'm going to give you, the agents are therapists. But if you were looking at the mental health system in a county or in a province, the agent might be the clinic, right? Or the agent might be the city in which clinics reside. Or you could have nested agents. So, okay. So what's an agent-based model? We have lots of agents, right? And as I said, sometimes at different scales. You can have teachers nested within schools, things of that nature. They have decision rules, right? If you remember that model I showed you, we have that peer influence yellow thingy up at the top, right? So here's an example where there's a decision rule. Do this if your neighbor does it. I actually should have used the word peer, but if you see your neighbor doing something, do A. If you see your neighbor not doing something, do B. Right? It's a rule. Made it up. It's a good rule, maybe. There are learning rules. If you do this twice in a row, continue to do it 90% of the time. Right? It's a decision rule. You can make that up. You have environmental specifications, right? Outside of these agents in this model I'm going to show you, the environmental specification might be the new treatment is 25% better than the old treatment. Right? Or it might be organizational support is high or low or medium or whatever it might be. And by the way, that specification is the treatment 25% better, you will see in a few minutes, is going to have a huge impact on whether or not people adopt this innovation and whether or not people are confident that the innovation is going to work. And by the way, one of the things we're going to see is that it's a lot easier to manipulate things so you get high levels of adoption than it is to manipulate things that you get high level of therapist confidence that the thing is any good or not. Whether that's good news or bad news, I guess, is another matter. All right, so I'm just going to review the bidding for a minute, and then we'll get into the simulation. Let's see, we have an evaluation scenario. That's that picture I showed you at the top. We have a logic model / program theory. It's the picture I showed you at the top. We know the limitations of the traditional valuation models, which is something we talked about, which is you can never understand the system well enough, no matter how good you are at developing those kinds of models. We're going to run the executable model. All right, but we need to give you the buyer beware lecture before we run the model. The program theory is artificial. We conjured it up for the sake of the demonstration. I mean, don't forget, we did this whole thing in a couple of hours. I mean, never mind, it took me longer to make this a fancy presentation in a way than it took to actually figure the whole thing out in the first place. My colleague Van Paranek probably put 4 or 5 hours into developing the simulation. I probably put an equal amount into thinking about the social science and evaluation implications. So we didn't have time to do anything but make up something that seems reasonable but may not be. thorough review of the literature might lead to a different model. One of the biggest problems in evaluation, at least from my point of view, and I teach this in my logic model workshops, program theory workshops all the time, is that most times that people put a program theory together, it's not really based on all of the knowledge that they have, which is a huge problem. And I can give you many stories about that, which I will forbear. Parameters in the model are only mathematical formula, right? In other words, when we put this together, Van said, okay, there's a relationship between confidence and use of the model, and he made up a formula, which I can show you if you have any interest, that sort of looks at that relationship. The probability of adoption, the steepness of the curve, the fact that it's not a straight line but it has an inflection point at some point. If you get too close to the boundaries of whatever scale you're using, you can get these ceiling and floor effects, and so the curve bends a little bit, but exactly where does it bend and how much it bends. He made up a formula that seemed reasonable at the time. But if you really wanted to do this right, you'd have to look into those assumptions. What does confidence mean? What does training quality mean? Made that up in a formula. So as I said, the reason I'm warning you about this is because it's going to look really sexy. And people are going to say, oh my God, we can do that, that's real. Well, it's not exactly real. It's very dangerous to use models to predict anything. And that is true. Now, it's also true that sometimes models are very good. I mean, if you think about the ability of the, who are the weather guys in the U.S. National and NOAA, National Oceanic and Atmospheric Administration, I think, right? They've got these models with God knows how many differential equations and God knows how much supercomputing power, but they are very good at predicting the path of hurricanes. They can't predict the strength of those hurricanes very well because they don't have enough data. But in the last 15 years or so, if they tell you a hurricane is going to take a particular track, they're pretty good at that. So it's not as if I want to say models are never any good or they're never accurate. But there are a lot of reasons, both practical reasons and theoretical reasons, which I promise not to get into, why you got to be careful and not look at models. Unless you have evidence to the contrary, never look at a model as if it's actually going to give you a prediction that you can trust. What it can do is give you some insight into the performance envelope of what you're doing. And so the way I'm going to run this model, and the way if you ever have models you should as well, is you play around with it, you run it a lot, you look at the behavior and say, aha, I see all this variation, I can learn something from this. Not, gee, if I set the parameters here, I know that such and such is going to happen. All right, so I think those are probably all of the necessary caveats before we get into this. I'm going to show you two scenarios here, okay? In the first scenario, the new treatment is going to be about 25% better than the old treatment, which, by the way, from my point of view, is great. My God, you've got some new treatment, it's 25% better. One of the things you're going to find is that it's not quite good enough if you really want to get high levels of confidence. It's not going to make much difference for adoption as long as there's strong organizational support. We talk about the value of that. And we're going to vary organizational support from high to low. All the other parameters are fixed, right? Because all the parameters in that picture that I showed you are here. Confidence in training, number of peers who use the therapy, all that stuff. We'll just set that at some reasonable mid-level, and I'm not going to mess around with it very much at all unless I have extra time. And you say, gee, what would happen if? And then we'll run that, and actually that could be a lot of fun because we'll actually begin to see how the system works. In the second scenario, the organizational support is going to stay high, and we're going to vary the success rate. And again, we're going to keep everything else at mid-levels. And hopefully we'll have enough time that I can show you this. I can talk a little bit about the implications, and then what I'm hoping is you'll raise your hands and say, yeah, but what if training was lousy, or what if my peers really liked it better, or whatever it might be, and we'll actually see how the thing behaves. And then we can talk about what that would teach you. We don't need that. Whoops, how do I, wait a minute. No, I can do it this way. Oh, and there are a bunch of useful references at the end. This is a piece of software called NetLogo. It is an agent-based simulation program. It's cheap, as in free, right? You can go to the NetLogo website and download it. And if nothing else, they have a lot of examples of all kinds of stuff. And I would highly recommend, if you have nothing better to do, just to look at what's there, because it's extremely interesting. And by the way, all of this looks the same. If you go to the web, you're going to find a tab with the interface, a tab with the information, and it'll all look like this, every single one of them, right? You know, what is it? How does it work? How to use it? It'll be on every single NetLogo simulation. And then there's a tab, and that's the code that runs it. So if you go to the NetLogo website, you'll see dozens of interesting simulations, and they will all look like that. Okay, so what do we have here? On the top left, we have all those sliders. And those sliders are basically different ways of showing, of instantiating, if I use this technical term, the model that I showed you before. So for instance, plus a little bit extra. Organizational support is that third slider in the top row, and it goes from 0 to 1. We don't know exactly what organizational support means in the real world, right? But we made it up here. We've got the number of therapists, right? And we went from 0 to 50. The number of groups, right? And we did that because if you really think that the peers matter, maybe it makes a difference if everybody in the clinic is somebody you react to versus only a particular peer group, and so we can change that. We have the minimum quality and the maximum quality of the training. We have people's confidence on the left that the training is any good. We have adaptability, right? Knows how likely are you to do something if you see your peers do it. Success delta confidence, failure delta confidence. If you do something and it works, I don't mean that. If you adopt the therapy and it works, how much does that increase your confidence that it's going to work the next time? If you do the new therapy and it doesn't work, how much of that is going to decrease your confidence that it's going to work next time, and so on. We're keeping all that pretty well fixed at the moment. And let's see what actually happens. Oh, I'm sorry. So now, average confidence on the left, right? We're going to run lots of iterations of this, and we're going to see what happens to the average confidence each time. Percent adoption, ditto. What percentage of the therapists adopt it? Remember I said that averages don't matter so much. Well, they do matter, but that what happens, every single unit matters. That big black box on the right, you're going to see the therapists, little people. They're called turtles in NetLogo. I don't know why. But we set that at 50, and if you really counted, you'll see 50 of them. If we set it at 3, you'd only see 3 of them. And so for each iteration of this model, it is going to show you where each and every one of those therapists are with respect to whether or not they've adopted it and how confident they are in this. Let's see, is there anything else I need to tell you before we get this show going?
Hey, Jonny, would it make a difference in the sense of the actual learnings from the model if you set 500 instead of 50?
That we haven't done. My suspicion, the way we've run this is no, because if we run it at, if you run it at 3 or 4, then the whole idea of averages don't matter much. If you go at 20, 25, 30, 40, it doesn't make a huge difference. I doubt that. I mean, the real answer is I don't know, but if I had to bet money, I'd say it wouldn't matter. Okay, so let's run this. The one thing I'm going to do, though, is bring the number of groups down to 2, just because otherwise you get an awful lot of lines here. Okay, so again, we've got 50 therapists. Organizational support is set at 0.26. I'm going to say 0.25, but I have sort of trouble getting the slider exactly right. The success rate I was going to set at 0.25, meaning it's 25% better, but again, I had to wiggle the slider, so we get 22%, but it's okay. And let's set this thing up. I'm going to let it run for a while. You can see all kinds of neat stuff, then we're going to talk about it. So we're just going to talk about this for a while. What do we have? 100. Let's go a bit more. All right, we have about 215 iterations. What does an iteration mean, by the way? What it means is we take all of these therapists and we drop them into cyberland. And every one of them has a certain set of conditions, right? There are certain global conditions everyone has, like how much organizational support is there, or how good is the therapy. Those are environmental conditions. And then on a random basis, each one is going to be set the individual parameters. How good was the training for me, set within those limits? How confident am I that the therapy will work, set within those limits? How high quality, how good was the training? And there's a range. Pick a random variable, give that to that therapist, set within those limits. So we take these 50 therapists and we drop them into the cyber world, and every therapist looks around at all the therapists around them, and they make a decision based on these rules. Am I going to use this thing or not? Well, once they do that, the world has changed, right? Because some have used it and some haven't, and some people's confidence has gone up and some people's confidence has gone down, and the average confidence of all your peers has gone up or down, etc., right? So now we have round number 2. Every therapist looks around. Oh, what am I going to do now? And we have these rules, right? And they go ahead and they behave. Okay, and that's how this thing works, and we've done that for 215 times. So you can see those 3 lines, both for confidence and adoption, you see 3 lines, and that's because we have 2 groups up there, and so you get 1 line for one group, 1 line for the other group, and then the line in the middle is the average. So you can see why I didn't want to have too many. Well, let's just do it, and you'll see what will happen. If we had more groups, I don't know, let's say we've got 5 of them, it won't make any difference. You'll notice the pattern's the same, but the variances for the different groups are a little bit different. And you will notice that those therapists on the right, can people see the black field? Is there too much light in the room? You okay? I don't know what to do about that. You can sort of see them? Kind of? I can't control the color of those. That's the problem. I can't help you with that. I can't say if we're going to have 2 groups, let's make one red and one yellow kind of thing. I'm sure there's a way to do it. I don't know how to. So hopefully people can see it. So what we have here is the average confidence level for each of those 5 groups. We have the percent of adoption for each of those 5 groups. And on the 108th iteration of this thing, that picture in the black is where each one of those 50 therapists are. And you will notice they're, for the most part, pretty low on confidence and pretty low on adoption as a group. And that makes sense, because if you look at adoption and confidence on those graphs, they're pretty low. And so you would expect most of them to be pretty low in the lower left, and they are. But that picture on the right are not averages. That's each individual one. And by the way, you'll notice there's a split. Can you see enough of this to see that there are a couple of therapists out on the right-hand side? That part's okay? Okay, you'll notice there's that big split. That's going to be an important thing, and we'll talk about that in a minute. But so for this particular simulation, let's just goose this up a little. Let's say, well, you know, if we really believe this is a best practice and the clinic is doing right, you're going to get more than 25%, rather 0.25 organizational support. Let's say the organizational support gets a little better. Let's bring it up around 50 or so. Let's run this for a little bit. Oh, how many iterations? We'll go to 200, 215, doesn't matter. Okay, so what do we see here? Well, the average confidence, you know, actually this is tough to do. I'm going to bring this down to a single group. It's just going to be easier to read. It won't make a difference in the pattern. It's just a little bit easier to read if you're only looking at one of these things. What did I do just now? I said, well, it's a simulation. I can do what I wanted. The first thing we did before was to say, let's say we have 5 groups of therapists, which means that any therapist is assigned one of those groups, and it's the social influence of only that group. Now I simply said you're looking at all of them, and by the way, it doesn't make a big difference, but it certainly makes a difference in terms of reading it. So what we see here is the confidence has gone up a little bit, right? Why that should be, I don't know, except we might hypothesize that if there's a lot of organizational support, there might be some increase in your belief that this thing is going to work. And the percentage of adoption has gone up. If you remember the previous version, right, adoption was way down, maybe not at 0, but pretty darn close to it. But you can see things are beginning to come up. Well, let's go up to a higher level of organizational support. What do I have here? 0.78. Well, now, I don't know if this is good news or bad news, but it gets pretty interesting. What do we see here? We really haven't had much of an effect on confidence at all, right? That hasn't changed, but adoption's getting a lot better. Now, is that okay or not? Maybe it is, right? I mean, if you're running this program and you've got a whole lot of research behind this new therapy, and you know that it's 25% better than what they did before, we're assuming costs and all that stuff are the same here, by the way. So now people are using the new therapy. What do you care whether or not people really believe it's going to work or not? Maybe that's true, but maybe that's not the world that you want to live in, because you think that maybe therapists will change jobs, or it's not a very good sign for implementing other kinds of innovations, or it just bothers you on some aesthetic level that they're doing it only because you're making them. So it's a judgment call as to whether it's a bad thing or a good thing, but one of the things we see here is that organizational support has a huge effect, and we will talk about that in a minute. Again, notice that split, right? You've got a bunch of people on the left, a couple of people on the right. You don't see it for adoption. There's a pretty smooth range of adoption, high to low, but you see that split on confidence. And just for grins, as my friend would say, let's goose up this organizational support really high. Same deal. They're really, I didn't actually, if I wanted to, I could take this little thing here and go down here. You'll notice it actually reads, 0.31, 0.277. I could actually, record that each time. I'm not bothering. But if you kind of look at this, what are you seeing, right? We certainly haven't seen much change in confidence, but the adoption goes way up. So what we're seeing here is that there's a big effect of organizational support. Well, is this a good world or a bad world here, right? What you're really saying is that if you've got something that's 25% better and you've got very high adoption, you're going to be able to get people to use this thing. Now, we haven't operationalized organizational support. Is it your boss is encouraging you to do it? Is it your boss is observing you? I mean, we don't, is it that your boss and your boss's boss are somehow supporting its use with public pronouncements? We don't know what that means, but whatever it means for organizational support to be that high, I don't know about the organizations you work in. The organizations I work in, if you're actually dropping some innovation in, it's not that common for organizational support to be really that high. So do you really care about this? Now, from an evaluation point of view, you might want to say, I have not thought about doing in-depth interviewing of the people who run these clinics to figure out what it means when they say that they're supporting this innovation. 10 minutes, no problem. Now that I'm looking at this, maybe I better change my evaluation design, because understanding the nature of support is going to really matter. Or you might say, God almighty, look at this. We've got all of these things, and we can't seem to budge confidence. Maybe I really need to do some in-depth interviewing of my therapists to get some idea of what confidence really means for them, and why, even though they're getting organizational support, their confidence isn't changing. And my God, here I got this therapy that's 25% better than what they used to do, and it doesn't seem to make much difference. Now, these are obviously design questions for your program, but they're big evaluation questions. So let me quickly, let's look at these individuals, right? We're going to go to this guy here. And that's turtle 30. I think it's watch, if I remember correctly. And now, instead it says normal speed. I'm going to slow this down to make it a little bit easier to see how people move. That's it. This is simply how quickly do the iterations go. And we want to watch this guy or woman. We don't know, as the case may be. So it's going, whoops, what happened to watching that person? I guess we need to. All right. See how that person moves at each iteration? Do you see them jump to the high side and back and forth? You can see that, right? Want me to make it go slower? Or can you see how? Now, this is pretty interesting stuff, right? Because what this is telling us, it's not, I would have figured, well, when it comes to confidence, once you get to believe the thing works, you believe it works. If you think it doesn't work, it's going to take a lot to change your mind. What we're seeing here is not that. What we're seeing here is that, and again, don't forget, each of these is an iteration, right? I look around, I see what's going on. I act, I look around, I see what's going on. From one iteration to the next, you can jump from very low confidence to very high confidence. Now, again, there's an evaluation question here, because do I only care about average confidence, or does it matter to me why people change their minds so much? And you might hypothesize, as we have, the reason that it jumps around so much is because failure makes a big difference. And so if you see things fail a few times in a row for random bases, it's going to blow your confidence. Well, if that's really true, there are design implications, which is maybe we need to work with therapists to explain reasons for success and failure. But it also has evaluation consequences, because it means you have to monitor confidence much more carefully than you might have. 5 minutes, maybe?
You're doing well.
I'm doing well. Okay. Let's go back to the other version now. We're going to take organizational support and move it down to something like mid-level. And if you remember, when we do that, it looks kind of like that. We've done that before, and you'll notice we still have this gulf here. And if I were to watch these turtles, they would, in fact, trust me, move around. And let's move this up to 2, just because it's a bit more interesting, although it's not going to change things. But now,
Jonny, those clusters you're seeing.
Yeah.
So what's the big deal?
Stop the 5 minutes. Go on.
That's right. What's the big deal? So what? I'm saying big deal. Right?
It's a big deal. It's a big deal because what it turns out is that almost no matter what scenarios you run, you're always going to have some therapists where there's a big divide in confidence, and as individuals, they're going to jump from high to low at each iteration. So it's this notion of their individual behavior changing so radically, well, confidence, psychological state, not behavior, that their psychological state is going to change so radically from one patient to the next. That's what makes it clinically interesting. Now, maybe you guys work in clinics like this, and you say, oh, we see that all the time. That's not surprising. But I don't, and it was surprising to me. And even if you can figure it out, the model will behave in other ways. There's nothing we can show in this model that in retrospect you won't say, yeah, I can understand that, I can explain that. But you would do that for every single anomaly. But if you were doing it from the beginning when you were putting in that original logic model, do you really think you would have foreseen all that stuff? That I would bet the answer is no. So now let's see, organizational support is in the middle. Let's bring the success rate up around to 50%. Now remember about, where we are here, right? And I'm using 2 just because it's sort of pretty. Right, so now what we're seeing here is that if you've got a therapy that's 50% better, you can bring your organizational support down a little bit, and the average confidence goes way up. So now we're talking about the importance of the therapy. Well, let's go even higher, and we're going to see what happens. Then we'll stop, and you guys can choose the simulations you want to run. But let me just show you this here. Oops, come on. No, I'm sorry, that's support. We want this guy here. All right, now you're 75% better. It's sort of around maybe 50 or 60. All right, it's stabilizing. So, 50, we got 54 of them, however many we have here. Okay. Well, so now we make it look better, and the percentage of adoption is quite high. I don't remember what it was in the previous run, but probably not too much lower than that. It was a bit lower. So what we see here is that adoption goes up a little bit, which is interesting, right? But confidence goes way up here. But remember we talked about earlier, we said, do we care about the gulf between confidence and adoption? Well, we can get them equal and high, but we're talking about a therapy that is, what did I set it at? 75% better. That is awfully high. I mean, as I said, I'm not an expert in this, but I imagine if you were, doing vaccinations or something, you can see these huge kinds of effects. But I would imagine for a lot of the kinds of things that you and I do, you wouldn't. I mean, I guarantee if I was evaluating a safety program and I could reduce accidents by 25%, I would think it's about the greatest thing in the world. The idea that I could reduce train accidents by 75%, that's never going to happen. So again, and you see that split there, but this has evaluation implications. First of all, it has evaluability assessment implications, because people are setting up this program and talking about how great it's going to be, and you're going to look at this, you're going to say, well, guess what, folks? I've looked at the research literature on this innovation, and it's about 30% better than what you would have otherwise, right? But we're going to run this model, and we're going to see that unless you, and if all you care about is adoption, that doesn't matter all that much. But if you also care about how confident your therapists are, you're going to be disappointed. And is that okay or is that not okay? So that's sort of not an outcome or process evaluation, but it's an assessment, evaluability assessment implication, because what you might say is, you guys are setting yourself up for failure. I'm a really good evaluator. And if you really want me to measure the outcome of this program, I'll do it. But let's take a look at this model, and let's take a look at the research literature. You guys are going to be in trouble. You want to pay me to evaluate the program? I can do that. Anyway, we could go on here, but that's the general point. And he's about to move. But if we have any time at all, if anybody's curious and they want me to change any of these parameters and see.
Hold that for the discussion sections where you have a more
Sure.
space.
Anything you want to do.
So, Jonny, thanks.
My pleasure.
So,